The world has continually explored the sky and reached far beyond into outer space. Aerospace technology is a strategic technology that determines national security, public safety, and national competitiveness as a high value-added growth engine. The Korea Aerospace Research Institute, KARI, is a specialized research institution with a mission to contribute to the nation's economy and the quality of life. KARI undertakes national aerospace R&D projects and, to achieve its mission, is actively engaged in exploring, developing, and diffusing new technologies in the aerospace sector. In order to become a leader of the aeronautics industry, Korea Aerospace Research Institute is endeavoring to develop the higher technology in the aerospace field. In the manned aircraft area, KARI has successfully developed key components of a Suryeon helicopter for both the private and military sectors, and is pushing for development of future aircraft such as private airplanes, as well as core technologies for civil helicopters. In the unmanned aircraft area, KARI is the second company in the world that successfully developed the tilt-rotor Type Smart UAV. Also, KARI developed an optionally piloted vehicle, eco-friendly high-altitude long-endurance motor-powered UAV, and quad-tilt-prop motor-powered UAV. Furthermore, KARI's unmanned vehicle advanced core technology R&D for preoccupying the fourth industrial revolution technologies and disaster and public safety multi-copter R&D for stereoscopic mission in disaster field are underway. Also, KARI is planning to establish the National Flight Testing Center and the Unmanned Traffic Management System. KARI is carrying out space development programs to secure independent space development capabilities as a part of the basic space development promotion plan. KARI is developing and operating low Earth orbit remote sensing satellites equipped with optical and synthetic aperture radar and infrared observation capability, including geostationary satellites that are capable of meteorological, environment, and marine observation. KARI has developed and launched 5 low Earth orbit satellites, of which 3 are currently operational. COMSAT-3 has a 70-centimeter resolution optical payload. COMSAT-5 has a synthetic aperture radar payload that can provide all-weather observation data of Earth day and night. And COMSAT-3A has a 50-centimeter resolution optical payload and an infrared payload. KARI is also developing COMSAT-6 and COMSAT-7. COMSAT-6 is an all-weather Earth observation satellite with enhanced imaging radar performance. COMSAT-7 will have a precision higher than 30 centimeters resolution image. KARI has developed medium to large geostationary satellite technology and has so far successfully launched 3 geostationary satellites, COMS, GeoCOMSAT-2A, and GeoCOMSAT-2B. These satellites support next-generation satellite broadcasting and communication, as well as independent oceanographic and meteorological observation. The GeoCOMSAT-2A and 2B perform meteorological observation faster and more accurately than COMS. GeoCOMSAT-2B can perform oceanographic and environmental observation around the Korean Peninsula. The COMS, GeoCOMSAT-2A, and GeoCOMSAT-2B have been contributing to the people's lives by monitoring weather and marine conditions, as well as detecting levels of air pollutants such as fine dust. KARI is also developing a next-generation 500-kilogram class mid-size satellite and will hand it over to industry partners through satellite technology transfer in order to support the domestic satellite industrial base. The image information acquired from these high-tech satellites is crucial in order to improve public safety and quality of life through such use cases as land and marine management, environmental and marine pollution analysis, and disaster response. It also helps meet public demands by opening high-quality images to the global satellite image market. The data collected by the satellites may play a crucial role in taking the lead in the fourth industrial revolution as an important information asset of the big data industry. KARI is developing KASS with the development of the localized satellite-based augmentation system, which will be capable of correcting GPS errors to within 3 meters to provide more accurate position information. KARI aims to improve aviation safety and lay the foundations of the future air traffic system, as well as establish a satellite navigation system by 2034. In addition, KARI is developing a technology capable of providing sub-meter class high-precision location information, that can be applied to autonomous vehicles and an indoor location determination technology that can quickly check the user's location inside a building. In the launch vehicle area, CARI is pushing forward in acquiring independent satellite launch and space transportation capabilities through space launch vehicle development. CARI has secured the launch vehicle system design, integration, and test technologies, upper stage technology, and key technologies for the 30-ton class liquid engine through the NARO development program. On this basis, the Korea Space Launch Vehicle 2 is under development with the objective of launching a 1.5-ton class satellite into low Earth orbit. KSLV-2 is a 3-stage launch vehicle using a 75-ton class liquid rocket engine as its main engines. KSLV-2 uses 4 main engines on the first stage, 1 main engine on the second stage, and 1 7-ton class engine on the third stage. In 2018, CARI successfully test-launched a single-stage test vehicle aimed at ensuring the performance and reliability of the 75-ton class liquid rocket engine to be used for KSLV-2. KSLV-2, slated to be launched in 2021, will open Korea's future space era as an independent space transportation medium capable of launching its own satellites and moon exploration. In addition, the NARO Space Center will play the role of an advanced base for space development, including the launches of KSLV-2 and lunar probes, by installing advanced facilities and equipment such as launch pads, launch control building, launch vehicle assembly facility, and tracking radar. CARI has been carrying out long-term space exploration programs, including lunar exploration, in order to develop the core technologies and to extend the working territory in space exploration. Currently, the Phase 1 project of the Lunar Exploration Program is underway, which includes the development of an orbiter equipped with scientific and technology demonstration payloads and the construction of a deep space ground station. In Phase 2 of the lunar mission, CARI plans to demonstrate its space development capabilities to the world through launching an unmanned lunar lander. CARI has made a remarkable growth in the aerospace industry in a rather short period of time. Such growth was made possible with enthusiastic R&D activities and strong support from the government and the people. Building upon the valuable achievements made, CARI will continue to develop and improve upon vital technology that will lead the competition of the aeronautics industry. Our dream towards the exploration of the sky and beyond into outer space will continue as Korea becomes a strong power in the aerospace community throughout the 21st century.